total differentiation. Alright, total differentiation is something that deals with the correctness and or the exactness of an answer of a function. So what do I mean about it? Right? So a function z is equals to x squared y minus 2. Alright? And therefore find delta z and dz, where x is equals to 4, y is equals to 3, and delta x and delta y are this value. Alright? And also you may wonder why are you carrying really anyway, so yeah, I think that it might be helpful if you feel that you are stressed right now. Just on that thing and then just listen to the rain. It's pretty cool. I don't know what I'm done doing, but yeah. Anyway, let's continue to total differential equation. So how do you solve for this and this, and what the hell are these two, right? So fear not. This term over here is an actual value approach, and this term right here is an approximate value approach. And the equation that they use, alright, for the approximate one is the standard equation, the general equation that you should, remember of. It's this term. Sorry, shouldn't put it as d, I should put it as partial f dy. Alright, if you don't know anything about this, it's okay. This is just a general equation. I would suggest you just remember or take it as a important stuff. As for actual value approach, I would just write this as this one, minus away the function of x and y. Alright, where x bar or y bar, let's take it as x bar first. X bar is equals to x plus some delta x. Alright, so there's some value plus some uncertainty. That's all it is, or some changes, small changes that is, with it. So with this two equations, then we can find in terms of the actual value approach and approximate value approach. Alright, so total differential equations have two types, the actual value and the approximate. Alright, so if you want to sometimes you want to calculate things in terms of easier one, you can use approximate value because you are doing things in terms of differential, so it's slightly easier than when doing actual value, which is sometimes if the function is very complicated, you can sub in until you siao. Okay, and therefore what we're going to do is to solve for the actual value approach first, alright, and get the answer, and then you will know what the hell am I talking about. So the function of z is equals to this thing, so I'll just paste it over here, and this is easier for you to see. And the definition states, the equation definition states that you're going to have a function where it has some bar over here and then minus away its initial function. So what you're going to do is to just first initiate the x first. So we know that x is equals to 4, and then its uncertainty value, this delta x, it's somewhat del x and dx sometimes is very closely related because both of them describes very small changes, right? This one is talking about changes, this one is talking about very small changes, and yeah, I don't know, but anyway, so I will take this as a very small changes in this case. So x bar itself is equals to x plus some delta x. So I'll just have 4, since I know that this is, I'll just pull this up a little bit. So this is 4 plus minus 0.01 f 3.99. Okay, so therefore I just sub in 3.99 square in x as a x first, and then y is 3, so y bar is equals to 3 plus this term over here, 0.02, I have 3.02. Alright, so I have 3.02 plus 3, sorry, this is minus actually, 3.02. So in fact this is x squared y minus 3y. This is what the thing is. And this whole thing that I've just written over here is the function of x bar and y bar. And then I gotta sum this up together. Alright, sum this up together and minus away the initial function where we sub in the initial value of x and y. But because I've written things in such complicated ways, so let me erase some things. Okay, this is neater now. So I got a minus. Alright, this whole thing is my function x bar and y bar. Alright, and then now I can sub in the values just for the initial things. So I'll just sub in the true value of x and y, and that's all. So therefore I have, you know, that x is equals to 4, so 4 square, and then times 3 where y is equals to 3, minus 3 where y is equals to 3. So this term over here is function of x, y. It's a pure value of it. If you were gonna elaborate, okay, I will count for you. You will have 0.018720. Okay, I don't know whether is it 02 or 20, but anyway, this is the answer. So this is the answer for where it is equals to del z. Alright, and this is for the actual value, right? Because it's actual value means that it's very actual. You have a lot of decimal places. My calculator will show a lot of so-called the decimal places. If it's a approximate value, the answer is very somewhat like a rounded off answer. So what do I mean? Alright, so let me paste this this thing again. I paste it over here. Okay, this is the function that we are asked to solve. So this is the function, and then now I use this thing. Okay, I place it over here. So now we are solving in terms of the approximate approach. Okay, so let me clear up. So we have an approximate approach. Previously, this one is the accurate approach. Okay, and therefore dz is equals to so I gotta partial the function in terms of x. If I do that, I will have 2xy. That's all. Okay. Plus and then dx plus partial f partial y is x squared minus 3. So if this term is partial f partial y. Okay, so let's clean things up a little bit so at least you. So to make it clear, okay, this term is partial f partial x. This term is partial f partial y. Okay, I'm just taking this term and then differentiate in terms of x and y, and I just do it up. If you don't know what is partial differentiation, and if you don't know what the hell am I talking, go and search for partial differentiation. Okay, and then you should see Patrick JMT. Please click him. It's a very good video. So you'll just teach you about the simple partial differentiation. Once you've done that, you can just come back here and then continue. But if you feel that this is fine, and then you just continue, right? So now we know that this is the equation already. So now we just sub in all our values. Alright, so I just paste these things, and then I'll just bring all the way down. Okay, so I'll just sub in my x, my y, and my this triangle x as dx. Okay, so when I do that, I have this one. Okay, this is simply 2xy. This is dx. This is this term. This is this term. Okay, I'm just simply subbing in my stuffs. Okay, I'm not cheating you any feelings because I know that I love you. Ajay, what the? If I do that, this term will becomes minus 0.24 plus this term will becomes 0.26. At the end of the day, I would have 0.02. As you can see, this answer equals to ZZ is a rounded off answer from the one that we have just calculated earlier, the accurate approach. See, 0.0187 blah blah. This one is 0.02, which is rounded off from here. So as you can see, this is some approximate answer, and while this is some actual approach. And this is the somewhat the understanding of a total differential type of questions that people would ask. The next video I'll talk about is will be very related to the approximate approach. Alright, so and I shall see you there in the approximate approach, and then good luck.